Computer memory management, its principles and algorithms. Introduction. It is paramount to guarantee a high quality of memory management or operating systems, OS, to be competitive in the modern market. Understanding resource management and how processes and OS govern it is vital to creating a stable, safe, and usable environment. This essay will discuss memory management, its principles, algorithms, and methods, and explain the differences between logical, virtual, and physical, real addresses. Principles. Several core concepts outline the goals of memory management. The primary principle is the most efficient allocation of memory by all operating programs. It is necessary for each program to function without causing disruptions to other processes. An OS must clearly outline the boundaries of each program, ensuring that each byte is adequately marked as free or allocated. Moreover, depending on the goal of each application, the portion of memory it uses must be secured yet made available under proper requests to keep its functionality intact. A system is only as functional as it allows the scalability of new and existing resources to be appropriately incorporated into its processes. Any OS relies on these principles to present its users with feasible functionality. Algorithms. Memory management relies on algorithms that allow systems to map addresses in a way that will be usable by other programs. The first algorithm that reads all available physical addresses occurs when a computer's hardware initializes memory read to outline OS and processes necessary base spaces and limits. CPU later utilizes this data to reallocate this memory in accordance with program's necessities, analyzing their requirements and limitations to ensure the most efficient usage of existing physical space. User programs also follow similar orders to ensure step-by-step execution. Their initial goal is to compile a code that will begin the process of memory allocation. The object files are then selected to be loaded and utilized through a software's functions. This function of management is critical for the stability and clarity of all operations within an OS. Methods. Optimizing these algorithms requires modern methods to be open to complex manipulations. For example, dynamic loading is an approach to memory allocation that loads data only when called, leaving space as available for other processes as possible. Dynamic linking is a regularly utilized method that creates libraries accessed by different processes with similar functions. Static linking is a less preferable method, as it treats libraries as objects loaded into memory by a program alongside its image. All these techniques give an OS an advantage in managing limited hardware space without the need for constant expansion. Logical and physical addresses. There are two types of addresses that OS utilizes in its processes. The first one is the physical address, which represents the direct physical location of any given data on a device's memory unit. This information is constant and unavailable to users openly, requiring a program to assign a logical address to it. Unlike physical addresses, logical ones are generated by the CPU at the moment a software requests one to be assigned for its operations. Logical addresses can be shared or briefly passed between programs to ensure communication. These addresses create an ever-changing environment that supports processes that would be otherwise too complicated to implement. Conclusion. In conclusion, memory management is a set of functions and techniques aimed at distributing any available space for programs in the most resource-efficient way. An OS has a complex set of mechanisms that govern memory usage, considering programs' requirements and limitations. Algorithms and methods behind these processes enable users to access data by creating necessary links for any stored information. Efficient manipulation of physical and logical addresses is what gives an operating system an advantage.